Hey everyone, today's assignment is this worksheet. Hold on, let me zoom out a little bit. On graphic motion. So in front of you, you should have this. Either it's on your Chromebook or you have the printed copy. I'm going to walk you through this a little bit today. But first, before we get started, let's review motion. So, motion. Motion is a change in position measured by distance and time. Speed tells us the rate at which an object moves. Velocity tells the speed and direction of a moving object. Acceleration tells us the rate, speed, or direction changes. So if we go back to the beginning of the school year and we did those distance versus time bar graphs, remember, time is always going to be on your x-axis and distance is always going to be on your y-axis. So, when you're looking at these different motion graphs, we have to go back to the beginning of the year and remember what this line means. Remember, when we see a straight line, and I'm going to zoom in just a little bit. Okay, when we see a straight line, that means an object is at rest. All right? Nobody's moving here. Time is going to continue to move, but your distance is not. Because remember, time waits on no man. However, your distance, you're standing still. We're not going anywhere. Time is just not going to wait for you. So again, object isn't moving. And this is speed time graphs. So here we're measuring how fast something is going in an amount of time. So when we look at this slope here, we can see that over time, this object is accelerating because it's moving in a constant distance, in a constant direction, and it's getting faster. It's accelerating. It's not here anymore. We're here now. So this shows an increase in speed, which means that object moving is accelerating. When we see a line that looks like this, that means the object is decreasing in speed, and we like to call that deceleration. So once we see this, we know that this is deceleration. And when we look at this, we have to differentiate which line is moving the fastest. Because again, we are trying to focus on speed and time. So, how we find out which line is moving the fastest is determined by the steepness of the line. Which line is the steepest? So, you have this dotted line and you have your solid black line. When you look at these two lines, I like to say if you were sitting on the top of this dotted line, or you was and your friend was sitting at the top of the solid line, which one of you guys would reach the start point first? Which line is the steepest? That's obvious, the dotted line. So, both the dash and the solid line show increasing speeds. However, one of these lines is moving faster. It's showing a greater acceleration. A speed time graph shows us how the speed of a moving object changes with time. The steeper the graph, the greater the acceleration. A horizontal line means the object is moving at a constant speed. Remember this? It's moving at a constant speed over a certain amount of time. Just like this distance versus time. The time is moving, but the distance isn't. Same thing with speed versus time. Your speed remains constant. So we can say that this is 40 miles per hour, right? But it stays the same. This whole entire time this person is traveling or this object is traveling, they're going 40 miles per hour because this is a constant rate of speed over time. A downward slope line means that the object is slowing down. So when we look at this line, we can see the object is slowing down. It's a gradual acceleration here. However, we have a deceleration here. We're going a steady speed here, and we're going a steady acceleration here. Now that we've gone over a few things that we needed to, let's go back to our worksheet. So I'm not going to do this whole thing with you. I'm just going to get it started. It says, the graph in figure 1 shows data for two objects that start from rest and travel in a straight line. Interpret the graph to answer the following questions. So this is a distance versus time graph. All right? So now that we know that, let's look at our questions. Question 1. What does each point on the graph in figure 1 represent? So, figure 1. Each point on the graph. What do each point on the graph represent? I'm going to give you a minute. So, if we have distance and we have time, then what do we know? The speed. So each point on the graph is representing a different speed. What does line A tell you about the speed at which an object A moves? So your object A is the dotted line. Your object B is the solid line. What does line A tell you about the speed at which an object is moving? So you can go back to your reference. Excuse me. Well, this line sort of kind of looks like this line. So what does this line tell you? The graph shows increasing speed. The moving object is accelerating. So, what does line A tell you about the speed? The speed is what? Accelerating. It's going to ask you the same thing with object B. Now, it goes up, slants a little bit, and gets steep again. So, what can you infer from looking at this line? 4. The lines that connect plotted points on a graph are called the curve of a graph. What can you tell about the way an object B moved from looking at the curve? So, remember when you were going over the information from earlier in the lesson that I've given you in the directions on our Google Classroom, a curved line represents acceleration. So when you think of a curved line, like so, what can you infer in relation to object, which object is it? Excuse me, B. Here. All right, not going to give you that answer. I know you can do it. 5. Which object moves faster for 50 meters? How do you know? Again, we're looking at speed. So in order for you to figure that out, we have meters on this side. That's the distance. 50 is here. You're going to look at both lines and you're going to come over here. See where 50 is with the object B and 50 with object A. Okay? And then, I'm sorry, earlier I said object B. I keep forgetting. Object B is this one, and object A is that one. So, B and A. Just a reference for myself. You may want to do that as well. All right. So, in order for you to figure this out, remember our equation. Speed equals distance divided by time. You're going to have to actually get your point coordinates to find your distance. Well, we know distance because we said 50. So now you're going to be looking for your time. So actually, the problem helps you out. You're trying to find speed. We know 50 meters is your distance. Now you're going to plug in the time for object A and object B to get the answer to this question. Whichever one comes out on top is the one that's going the fastest. What was object A's speed? You're going to show your calculations. What was object B's speed from start to point B? All right. So again, set up your calculations. Look at object B's speed from start to point B. All right. From point B to point C. So remember, start to point B is here. You're calculating the speed. Then B to C, you're calculating the speed. From C to E, you're calculating the speed. What was the average speed of object B from start to from object B from start to point A? Remember, you're going to add everything up and then divide by the number of points when you're getting your average. So there's 1, 2, 3, 4, 5 points. So whatever number you get for the speed, you're then going to divide it by 1, 2, 3, 4, 5. And that's going to give you your average. Now, you can do this. If you want help with your speed problems, then look at my video from yesterday where I'm breaking down speed problems. And I'm using this triangle where you got the distance divided by speed and time. That's a little tiny, so I'll make it bigger. This is the tool that you want to use to help you solve these equations. But I was nice and I already helped you with what the equation looks like. Again, if you want to see how I break down how to calculate speed, please watch my video from yesterday. If you have any questions, please send me an email, give me a DM on Instagram, or you can write in Google Classroom. Have a wonderful day.